Hello friends, again welcome to JE Cloud, and this is your cloud mentor Gaurish. Hope you guys watched the previous video. So we are here for another question from JE and the full topic discussion on that. And in this lecture we are taking chemistry. You can follow us on different social media platforms. The links are given in the description box below. And daily we will upload at least one topic discussion. To get that videos on time, you can subscribe the channel and press the bell icon if necessary. So now moving to the questions. It is from 2020 JE mains and from the first shift of the January 7th. The first question is already discussed in another video. You can watch that video by pressing the I icon at the top right corner or by visiting the channel. So moving to the second question, the oxidation number of potassium in K2O, K2O2 and KO2 respectively is, and this question is about finding the oxidation number. So let's talk on that topic, taking some time. So oxidation number, the real or imaginary charge which an atom appears to have in its combined state is called oxidation state or oxidation number of that atom. The oxidation number or oxidation state of an element in a compound is determined as the number of electrons that have passed from one atom of a given element to the other atom. That is, that type of oxidation is called positive oxidation, and or to one atom of a given element from other atom, that is negative oxidation. We can also say that oxidation state is the oxidation number per atom. And for doing the problems on JEE, we must know to assign the oxidation number to the elements in a compound, or like finding the oxidation state of an element. So, and we must know certain rules before assigning oxidation number. And rules for assigning oxidation number, they are: the oxidation number of an atom in its free or elemental state is 0. For example, oxidation number of hydrogen in H2, that is in elemental form, and sulfur in S8, that is S8 is also its elemental form, and phosphorus in P4, oxygen in O2, and oxygen in O3 all have the oxidation state that is 0. We have the oxidation state as 0. And the next rule is the oxidation number of fluorine is always -1 in all its compounds. That's a notable thing. Oxidation number of fluorine does not change ever, and that is if fluorine has -1 charge or oxidation state. The oxidation number of oxygen is always -2 in all of its compounds except peroxides like H2O2, superoxides like NaO2, and oxygen fluorides like OF2. In peroxides, its oxidation number is -1, and superoxides, its oxidation number will be -1/2, and in OF2 the oxidation number becomes positive, +2, or the charge oxidation state becomes positive, that is +2. And the fourth rule, it is the oxidation number of hydrogen in metallic hydrates is -1. What is that? The oxidation number of hydrogen in metallic hydrates is -1, while the rest of the compounds it has +1 oxidation state. Most of the compounds the hydrogen have positive +1 state, but in metallic hydrates like NaH, because the oxidation state of the group 1 elements does not changes. So NaH, the hydrogen will have -1 oxidation state. In all other compounds they have +1 oxidation state. That means hydrogen have +1 oxidation state. And the next rule is the oxidation number of an ion is equal to the charge present on it. Or for an ion, take Na plus. Here Na plus, the charge will be +1, or anything like Cl minus or Mg2 plus. There for such ions the charge or the oxidation state will be the charge present in that. And for complex ions, the algebraic sum of the oxidation states or the oxidation numbers of all the atoms is equal to the net charge on that ion. That is the case of the oxidation. For the complex ions, we have talked that a lot in the chapter coordination compounds. And the next rule is that in case of neutral molecules, the algebraic sum of the oxidation numbers of all the atoms present in the molecule is 0. And you can take the note or screenshot by from this. Okay, so now we have the rules for assigning oxidation number, but we have to know some common oxidation states of some elements. And the most common oxidation states of representative elements are tabulated here. And the representative elements consist of S and P block elements, and they are the first group element, second group, 13th group, 14th group, 15th, 16th, 17th and 18th group. For the first group elements, the oxidation states are always +1. I have told before, that is like the sodium, and +1. And for the second group element also it is constant, that is +2. And for the 13th group element, they show the 2 oxidation states, that is +3 and +1, this group of aluminium. And the 14th group shows +4, +3, +2, +1, -1, -2, -3 and -4. And 15th group shows +5, +3, +1, -1 and -3. In that group, the nitrogen shows all possible oxidation states from the +5 to -3, including -1/3. It's a fraction in N3H. And for the 16th group, we are talking about the 16th group. So it have the oxidation states +6, +4, +2 and -2. And for the 17th group, it is they have the +7, +5, +3, +1 and -1, and all like that. And for the 18th group, it is the 0 group or noble gas. They have the oxidation states are 0. So moving on, for finding oxidation state of an element in a compound, we have to follow certain steps. The first step is assign oxidation state of all other elements except the one oxidation state which has to be found. Use the rules for assigning oxidation state of elements we have discussed above. And for example, in KMnO4, we have to find the oxidation state of manganese. So it is unknown, that is given as X, and we are assigning the oxidation states of the other, that is the potassium will have +1 and oxygen is -2, and we have assigned that. And the next rule, it is the second step is the algebraic sum of oxidation state of all the elements of a neutral molecule is 0. Yes, we know. And in case of ion, it is equal to charge on the ion. Okay. In case of KMnO4, it is a neutral compound. If for some compounds there may be charges. For example, I am taking an example of something like MnO4 minus, MnO4 minus. Here there is a charge. This is not a neutral compound. Then the total sum of the oxidation state will be equal to -2. And for the case of KMnO4, finding the oxidation state of manganese, we are writing like this: that is the we know the oxidation state of the potassium is +1, and the unknown value, that is x. And for the case of oxygen, for one oxygen the charge is -2, or the oxidation state is -2. There is 4 oxygen in the KMnO4 molecule, so multiplying by 4, and the total charge will be 0. That is +1 plus 1 plus x minus 8, that's -2 multiplied by 4. Okay, -2 multiplied by 4, which will be equal to 0 because it is a neutral molecule. And we get that is 1 plus x minus 8 will be equal to 0, and that is x minus 7 equal to 0, or x equal to 7. That is the charge on that manganese, or that is the oxidation state of the manganese, that is +7. So now we know the rules for assigning the oxidation number and the steps to follow for finding the oxidation number. So now we are able to do any problems from this portion. Not any problems, there are some topics like the fractional on the fractional oxidation numbers, and also some exceptional cases for the finding oxidation number. If you want to know more about that things, just comment below there in the YouTube. I will make the video and upload it for you. Okay, and moving for the questions. The question is, assign oxidation number to the underlined elements in each of the following species. And the compounds are given and the elements are underlined for which the oxidation number is to be assigned. So the first compound is here NaH2. The first one, it is NaH2 PO4. NaH2 PO4. Okay, here we have to find the oxidation state of the phosphorus, and let the oxidation state of the phosphorus be x. Okay, oxidation state of the phosphorus be x, and writing the oxidation number of each atom above its symbol. That's a step we have to take, and we get is Na+1, sodium +1, and for the hydrogen it is +1, and for oxygen it will be -2, right? And in neutral compounds, the sum of oxidation numbers of all atoms is 0. We know that, and by giving that here in there is only one sodium, so 1 plus 1, that is +1, plus hydrogen, there is 2 hydrogen, so 2 multiplied by this that +1, so +2, and there is only one phosphorus, when we have given x for that, x, and plus there is -2 for oxygen, and there are 4 oxygen atoms there in the compound, so we will get the sum as 0 because it is a neutral compound. And we get as 3 plus x minus 8, that is equal to 0, and that is we get x as 8 minus 3, that will be equal to +5, and hence the oxidation number of phosphorus in NaH2PO4 will be +5. Okay, we got the answer for the first one, and moving to the next one, it is the NaHSO4, and here it is the +5. Okay, here it is +5 for NaHSO4. Let the oxidation state of sulfur be x. Okay, sulfur be x, and assigning the other oxidation states. For sodium it is always +1, and for hydrogen here it is +1, and for the case of the oxygen here it is -2. So doing that, and we get the second one, we get that is a +1, 1 plus 1 there is only one hydrogen, and the charge of hydrogen is 1, or oxidation state of hydrogen is 1, and plus there's only one sulfur, and which is assigned as X, and plus minus 2 multiplied by 4, that will be equal to minus 8. Okay, minus 2 multiplied by 4, that will be equal to minus 8 and equal to 0. So we will get as the answer X equal to, we are moving this minus 8 to the right side, and it becomes plus 8, and this 2 is 2 becoming minus 2 here, and the final answer will come out to be plus 6. So here the unknown value, that is plus 6. Okay, here is plus 6. And for the third one, we are moving to the third one. Here we have to find the oxidation state of the phosphorus, and also we are assigning X phosphorus here. For the phosphorus it has X, and for the other one, that is hydrogen plus 1 and oxygen minus 2, and we are doing the calculation here. Is there are 4 hydrogen atoms, that is 4 multiplied by 1, that will be equal to plus 4, and 4 plus, there is 2 phosphorus, and multiplied by X, that is 2x, and there are 7 oxygen atoms, and for one oxygen atom oxidate is minus 2, so 7 multiplied by minus 2, that will be equal to minus 14, and which will be, it is also neutral compound, so that the charge will be equal to 0. So 2x plus 2x minus 10 will be equal to 0, that is 2x equal to 10, and so x will be equal to 10 by 2, that will be equal to plus 5. So here the x is plus 5, and for the next one, it is the MnO4 minus. It is a charged compound. Okay, and we have to find the oxidation state of the manganese, so we are assigning X for manganese, and for the case of oxygen it is minus 2. So doing calculation, and X minus, there are 4 oxygen atoms, and one oxygen atom has the oxidation to minus 2, so minus 8, and the total charge will not equal to 0 but equal to minus 2. That's the thing to be noted here, and X will be equal to this minus 8 comes to be plus 8 here, and plus 8 minus 2, that will be equal to plus 6, and here the oxidation state will be plus 6. For the manganese here, the oxidation is plus 6, and the next one, it is the calcium dioxide, CaO2, and let the oxidation number of oxygen, here we have to find the oxidation number of oxygen, let it be X, and we know it is the second group element, so it is plus 2. Calcium is second group, and it is constant, that is plus 2, and calcium is an alkaline earth metal, so its oxidation state is plus 2. Okay, and calculation, no, it is 2 plus 2 multiplied by 1, that is 2, and plus 2 multiplied by X, that is plus 2x. The total charge will be equal to 0 because it is a neutral compound, and that is 2x will be equal to minus 2, 2x will be equal to minus 2, and X will be equal to minus 1. Here the oxygen has minus 1 charge. Okay, so moving on to the next one, it is the NaBH4, which is hydrate. We must be aware of the hydrates, and assigning the unknown value at X as X. In NaBH4, hydrogen exists as hydride ion, that is H minus ions, so its oxidation number will be minus 1. It is hydride. Okay, the hydrogen here appears as hydride ion, so the oxidate will be minus 1. If we do it as giving plus 1 for hydrogen, then the answer will be wrong. So here we are doing the calculation, and for sodium it is plus 1, and there are only 1, and plus 1 plus X minus 4 will be equal to 0. sorry, will be equal to 0, and that is x will be equal to plus 3. X will be equal to, and for the next one it is the H2S2O7. H2S2O7. Here hydrogen will be plus 1, hydrogen will be plus 1, and sulfur X, oxygen also is minus 2, and 2 multiplied by calculation, 2 multiplied by 1, that is 1, 2, and there is 2 sulfur, so 2x, and minus 14, that is 2 multiplied by 7, minus 2 multiplied by 7, that is minus 14, and the total charge is 0. So we will get 2x as 12, 2x as 12, 2x as 12, and x will be equal to, can you read this? Sorry, I have no graphics tablet, I am using a mouse, so it is difficult, little difficult. So the charge will be plus 6. And the last one, it is the KAlSO4 twice 12H2, and we are going to assign the oxidation states. That is for potassium it is plus 1, and for aluminum it is plus 3, and for sulfur here it is plus 2. So sorry, it is not plus 2, it is to be found out, that is x, and for the oxygen it is minus 2, and for hydrogen here it is plus 1, and here for oxygen it is minus 2, and doing the calculations here, and it is plus 1 for that is potassium 1, plus 3 for aluminum, plus sulfur it has x, but there is twice, so 2x, and plus 4 multiplied by 2, that is 8, and the charge of one oxygen is minus 2, so minus 8 multiplied by 16, that will be equal to minus 16, and plus 12 I am taking common out, and 12 multiplied by the charge of hydrogen is 1, and there is 2 hydrogen, so 2 multiplied by 1, plus for oxygen it is minus 2, and the total charge will be equal to 0. So doing this we get 4 plus 2x and minus 16 will be equal to 0, and therefore 2x will be equal to plus 12, and so x will be plus 6. So we have done all that questions, and it is plus 6. And moving to the final one, that is the JEE question, which is also simple one. The oxidation number of potassium in K2O, K2O2 and KO2 respectively is actually very simple question, because we know that, and I have told that for the first group elements the oxidation number does not change, and it is the plus 1 for all, and that is, so the answer will be the option C at the first site itself. And in the case of the oxygen here, here for K2O there will be minus 2, and K2O2 it is a peroxide, so here it will be having minus 1 charge, and KO2 it is a superoxide, so it is having the oxidation state minus 1 by 2. That's just for your knowledge. It's not asked in question, but you must know that. There will be more videos uploading in the coming days, at least one video per day. We will do maximum discussions as far as possible, so stay safe and study well. And to know more about the cloud vendor, visit our website You can Google by typing Cloudmender Gaurish. Site appears as the first result, and or simply search Cloudmender and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving out your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.